Continuing on the topic of password security, on a shadow file on a Unix system, such as Linux, there is a prefix in the shadow file that tells you, along with the password, what hash function was used. So, if you have $1 at the start, that means it's MD5 based. $2 is Blowfish, which was created by Bruce Schneier and his team. There's SHA-2 base, which includes $5 or $6. And so, for example, if we look on this system, we can see that it's using SHA-2 with this salt and this hash. And if we wanted to change our password on a Linux system, there's the password command that you can use. So, password command, it asks for the current password, and then it prompts you for a new one. And that will actually, as a normal user, you can run that command, and it will update this shadow file that normal users can't, usually access. So you'll see here that this has changed. So it'll be a new salt and a new password hash as well. So there are a number of weaknesses to passwords, and we'll just discuss some of them. So password aging is one of them in terms of how you manage password aging. So password aging is where you tell someone they've had their password for too long and it's time for them to change their password. It used to be considered best practice to do this a lot, but generally speaking, if you do that, people end up with very bad passwords. They end up writing their passwords on post-it notes or just using, very bad passwords, because if they have to change their password every week or something, then it gets tiresome as a user. I can speak from experience. When you're forced to change your password all the time, it's really annoying. So generally speaking, you should give people notice that they're going to need to change it, and you shouldn't force them to do it any more often than they need to, really. It's good to know. One of the arguments for it is that obviously if a account's been compromised, then it limits the amount of time that they have access to that account before they end up needing to try and get access again. But really the benefits can be outweighed by the disadvantages if people end up using really bad passwords or get annoyed as a result. So some of the things that we do as countermeasures against specific weaknesses. So one weakness of using passwords is if we just store them, people can access the passwords. So the countermeasure against that is to hash them first. You might think that you should just like encrypt it instead of using one-way hash function, but there's a lot of practical reasons why that's not a good idea. You need to read that file quite often, or the system itself needs to read that file. There's no reason why you should really need the plain text version. So in almost all cases, you shouldn't. You should just use hashed versions of your passwords in terms of how you store them on a system. And if you're developing some software, then you need to store credentials somewhere. You should always hash them first. So an attack is to use dictionary attacks. So, for example, you just basically, an attacker tries all the dictionary words against the passwords. So the countermeasure there is to use high entropy passwords and actually use good passwords that are not just a dictionary word, and use an algorithm that takes a longer time to compute the hash. So it takes a little bit longer, does a few more rounds of computation, then that can make it more difficult for someone to do the password cracking. If you're doing an online attack, you can just build in a delay. So if you've got an API where people can try and log in, if they try and log in again from the same IP address, make them wait a little bit. Because that can, obviously make it harder for the attacker. You can also do things like make it take longer. If it's an online attack, you can build in increasing delays or lock them out at some point, but that can give the attacker a way of performing a denial of service against an attacker as well, so against a user. So brute force is where you try every possible password. So you try A, B, ABC, B. You know, you try like every combination of letters. The countermeasure against that is to use a decently sized password or a decent key size. And that will effectively make that impossible if you actually have a really good, strong password and a hash function that lets you use a good password and doesn't limit it to too many, like only a few characters. And you use a cryptographically strong hash function, then even an offline brute force attack can basically become impossible or computationally impossible. Even on modern systems. You can do pre-computed attacks that we discussed before, and the countermeasure is to use a salt or a large enough salt to mean that they can't pre-compute all the hashes in advance. And rainbow tables is a type of pre-computed hash that stores its starting points for long chains of hashed passwords, and the countermeasure for that is to use a salt as well. So a replay attack is another kind of attack, which is where we when we're authenticating over a network and the passwords are being sent over the network as a hash, then a replay attack allows someone to basically hear the password and use it again. So you like eavesdrop on the network, you see a hash being sent over the network, you grab that and you send it again. It's actually a common attack against Windows systems called pass the hash attacks. Where some of the network protocols that that Windows uses will send hashes of passwords over the network, and when you hear that hash, you can just replay it. So actually, before I wrap up with a conclusion, why don't we have a little bit more of a look? So actually, no, let's wrap it up, and I'll record it as a separate video. So in summary, we've talked about how passwords work. We've talked about how passwords are stored. We've talked in this video about how salts are used and stored, and kind of listed some of the kinds of attacks against passwords and some of the countermeasures that you can use. And I'll record one last video on the topic of passwords, giving just a quick demonstration of some password cracking.